Well, we're going to go over a couple of different types of bonds. And one specific one is called an ionic bond. I call it the give me that bond because basically what's going to happen is one electron is going to get stolen by another one, and then through that they're going to actually make a pretty strong bond between the two molecules. So if you look, here we have Na, sodium, Cl, chloride. You've probably heard of sodium chloride, table salt. You'll find that one of these guys has only one electron in its outer orbit. And this guy has 1, 2, 3, 4, 5, 6, 7. So if you recall back from a couple of slides, the last slide, we talked about them wanting to be in this octet or 8 electrons. So this guy wants one extra electron. And this guy over here either has to pick up 7 more electrons or just donate this 1 electron, and it'll do that octet rule. And again, octet means 8, and it just means that its outer orbit wants to have 8 electrons. So what happens in this bonding is that the Na will donate an electron over to the chloride. So now what will happen is this will have 8 electrons on the outside. And this guy will now, because he lost an electron, what's going to happen is he started out with, and you could look this on the periodic table, we can go back and look at one. If you look at nitrogen, you could see that normally, we were looking at chloride. He's over here, and you can see that he's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 electrons. So chloride over here has 17 electrons. Sorry, I miscounted. 17 electrons. He picked up another electron. So he's got 17 protons, 17 neutrons, and now 18 electrons. Because he picked up this electron and it went over here, 18. So that's going to make him slightly negative. Over here, because he's lost an electron, he's now slightly positive. So when one becomes positive and one becomes negative, they sort of attract, sort of like magnets. So we call a cation something that's positive. So it has more protons than electrons. And an anion is something that is negative because it's got more electrons than protons. So what happens here is that this guy has become slightly positive, so he's a cation. This guy is an anion, negatively charged. How I remember these two terms is that a cation, somebody with a cat, is positive. Somebody that ate a whole bunch of onions, because it sounds like anion, is negative because it's going to repel people. So if that helps you, great. And an ionic bond is when they're sort of oppositely charged. So again, this guy, Na, donated the electron, so he became positive. Cl got another electron, so he's going to be negative. So cation, anion, both of them have now occupied the outer orbits with 8. So the octet rule is now complete. And what's going to happen is because he's slightly positive and he's slightly negative, they're going to stick together, sort of like a magnet. So wherever a positive and negatives are, when we think about these things, we think that, hey, they're going to attract each other, they're going to stick to each other and bind. So that's kind of what you're seeing in this cartoon. This Na says, here, I have an extra electron, you take it. The Cl says, I only have 17, wanted to have the octet rule. They go ahead and share, and now they're stuck together because one has a positive charge and one has a negative charge, kind of like a magnet. And that happens with different elements, but this is basically what we would call an ionic bond. So just so we have it in place, the Na will go ahead and donate the electron to the Cl. The Cl will now become slightly negative. The Na will become slightly positive. We will have an issue where one is positive, one is negative. They stick together. So one's a cation, the Na. The Cl is an anion. The other thing that you hear a lot in chemistry is this. A loss of an electron means that you're oxidation or oxidated. And a gain of an electron means you've been reduced. So this guy gained an electron, so he was reduced. This guy lost an electron, so he was oxidated. So oxidated, reduced. How I remember these two, because they do pop up on chemistry exams. Leo the lion goes grr. So Leo the lion goes grr. Leo stands for loss of an electron, oxidation. Gain of an electron means reduction, grr, and that's how I sort of remember this process. So just so we can kind of keep each other on the same track, when it comes to these kind of bonds, the things that we've already covered and you should really know is that number one, chemistry and really anything in biology follows the equation that structure equals function. The way things look is the way they act. Each subatomic particle has a specific role, and you could see that these subatomic particles, when we're talking about chemistry, one electron going to one end makes a difference because it talks about how molecules come together, these elements start to bond to each other. And remember, an element is just determined by the number of protons. They're the smallest component. An isotope is determined by the number of neutrons. We talked about them in the last video because if you have more neutrons, you become slightly radioactive. And they're used in medications. They're used in diagnostic tools in hospitals to determine thyroid function and how the small and large intestines are functioning. And an ion is basically determined by the electrons. Our next video that we're going to do is going to be on covalent bonds.